Hello everyone, a very good day to you all. We from group HVAC want to present about development of automotive air conditioning system by heat pump technology. Okay, for introduction, the market for the next generation vehicles such as electric vehicle or EVs and hybrid vehicles HEVs and PHEVs is expected to expand in the future. However, because of problems such as shorter driving mileage, higher price, and undeveloped infrastructure, they have not yet become higher price. In particular, improved energy efficiency is required for air conditioning system used for vehicles to extend their driving mileage. Existing air conditioning system significantly decrease the driving mileage due to the electric power consumption during heating operation. Therefore, air conditioning system that reduce electric power consumption are currently under development. So, the current situation and issues. Okay, for the current situation, the heating operation of an air conditioning system on vehicle equipped with an internal combustion engine uses exhaust heat transported by hot water drawn into the vehicle cabin from the engine cooling system. For an electric vehicle, however, exhaust heat is lower than of a conventional internal combustion engine and is insufficient for heating operation since the electric motor has a high energy conversion efficiency and the kinetic energy of the vehicle is recovered as regenerative electric power during braking. At present, systems equipped with an electric water heater are commonly used to compensate for the heat shortfall. So the figure is the next slide. Okay, next. For the issue, although an electric water heater system provides beneficial features, it also gives rise to major issues when used in an electric vehicle. Its heating operation requires a larger portion of electric energy for the entire vehicle, and the driving mileage accordingly decrease. You can see from the figure 2, extending the driving mileage by increasing the battery capacity, however, creates difficulties with regard to battery mounting space, weight, and cost. You can see on the figure 2 on the pie chart. So, for the explanation for figure 2, it show the energy balance in vehicles equipped with an internal combustion engine. Exhaust heat from cooling loss is used for the heater. In electric vehicle, the electric power required for the heater is supplied by the battery. That's all from me. Thank you.
Okay, for the next part, I will be explaining about the application of heat pump air conditioning system to eco-friendly vehicles. So, for the selection of heat source and refrigerant, the heating performance of a heat pump system is greatly affected by the heat source that is used for heating, and thus, selection of the heat source is important. For a heat pump used in an automotive air conditioning system, possible heat source for its heating operation are as follows: thermal energy in the outside air and thermal energy from the ventilation air in the cabin. So in this research, existing refrigerant, the R134A, was used because of its availability and affordability. Table 1 compares heat pump system using the two possible heat source. As a result of this comparison, MHI selected the system using outside air for further inspection, owing to its simple structure and possible cost reduction, both of which are important factors in achieving wide distribution. The details of the system are presented below. So for the overview of the heat pump system using outside air heat source, the heat pump using the outside air consists of a compressor, a condenser located inside of the cabin, a three-way valve, a receiver and expansion valve, a evaporator located outside of the cabin, a evaporator located inside of the cabin, a condenser located outside of the cabin, and plumbing that connects this. It uses thermal energy in the outside air as the heat source for heating the vehicle cabin, as shown as figure 3. The heating performance depends on external conditions such as the outside air temperature, weather and vehicle speed. Hence, adequately investigating the influence of such condition is important when a heat pump using air heat source is applied to an automotive air conditioning system. So the component characteristic, the characteristic of the outside evaporator and inside condenser, both of which were newly designed for the heating operation of the system, are described below. So the evaporator located outside of the cabin for heating operation. The evaporator for cooling operation located inside of the cabin has a compact design and uses a double row refrigerant flow path to increase the heat exchange rate per unit area, allowing it to fit into a constrained mounting space inside the cabin, while attaining the necessary capacity. In addition, the heat exchanger surface has a special finish to prevent condensed water from flying off. The evaporator for heating operation, however, must fit into the constrained mounting space provided for the cooling component located outside the cabin, while attaining the necessary airflow. Accordingly, MHI adopted a thin low pressure loss design whose heat exchange rate per unit area is smaller than that of the evaporator located inside of the cabin. Since one must consider frost formation during heating operation, MHI designed the heating evaporator with headers at the top and bottom and a vertical refrigerant flow path, also taking account of dewatering.
For the next part, I will present about vehicle level heating and defroster performance. Performance evaluation test on an electric vehicle equipped with the heat pump system using outside air heat source yield the following result. Heating performance. To evaluate the heating performance, the electric power consumption of the heat pump system was compared to that of the electric water heater system, as the outside temperature changed from 0 degrees Celsius to 10 degrees Celsius, while the cabin temperature was maintained at a comfortable 25 degrees Celsius. Table 2 lists the test condition of figure and figure 8 show the test result. Next, I will talk about windshield defroster performance. A performance test of the windshield defroster in securing visibility at low outside temperature was also carried out. Table 3 lists the test condition and table 4 will present the test result. The result confirm that this heat pump system satisfies domestic regulation and defroster. In addition, the experiment verified the feasibility of continuous defroster operation. That's all from me, thank you.
Assalamualaikum. I'm going to end with conclusion and future prospects. So the performance evaluation of an actual electric vehicle equipped with the heat pump system using outside air heat source verified that the heating operation of the system can improve energy efficiency while continuously maintaining a comfortable cabin temperature at an outside temperature between 0 degrees Celsius and 10 degrees Celsius. In addition, effective defroster operation was confirmed even when the outside temperature dropped to negative 8 degrees Celsius. In the future, MHI will improve the integrity of the system by verifying the practicality under various driving situations. MHI already possess development technologies for electric water heater systems and aims to combine the benefits of the heat pump system and the electric water heater system to devise enhanced heating systems and meet user needs through cooperation with manufacturers of generations vehicles. Thank you.